Okay, let's take we're going to take a real quick look at the code, just a couple things in here that I want to point out on this particular program. These lines of code here for the Renishaw probe, first of all, we're coming down with the probe to 4 inches above the part, protected move down to 1 inch, and then we're going to probe a spot on the casting that I kind of described in the video, and we're going to set that to Z0 on fixture offset 1. And we're going to come back up to home position on the Z in the machine. Then we're going to set these variables. We're going to set 5241, which is G56 is X. And we're going to do this calculation to set the X on G56 or 55, excuse me, G55's X 0. We're going to set the Y0 to equal this number here is the G54's Y0, pound 5222. Then we're going to set the Z0. We're going to do this calculation here. Now these 43.334 dimensions here and here are the center line of the rotation of this fourth axis, or the B axis on this horizontal mill, from the zero return or home position in the Z axis. The machine zero of the Z axis is 43.334 inches to the center of rotation of the B axis. So with these calculations, I can actually just calculate and set the 0 point of the other fixture offset based on the rotating 90 degrees and doing a calculation, because I know the 0 point in Z is down this far, and the 0 in X is on the 0 of the machine zero, the center line of the rotary axis on this horizontal mill. So I can actually calculate this other fixture offset ideal position. Basically, I can calculate it. I don't need to actually probe anything, because there's nothing machined to probe anyway on the casting. So just wanted to show that little detail. And then down here on these boring cycles that I'm going to bore these holes. Now typically what I do on a boring cycle, this is going to be the half-inch dowel pin holes, and these are the boring, the program to do the boring, but that's not what I want to show here. What I want to show is that instead of having to restart the program over and over again to rerun this boring head, because you typically have to run the boring head maybe about 3 times, you back it off, you run it, you measure it, you adjust it a little bit, you run it again, and it takes usually about 3 times to get a bore to size like this. And instead of having to restart the program over and over again, what I do is I put a program stop at the end of the boring cycle, and then I put this go-to statement. It's going to, with an optional stop, or an optional block delete I should call it. This forward slash is a block delete in a program. So if you have the block delete key pressed, depending on the way the control works, but on this machine it's a button. You just push it, and it'll skip any line in the program that has this forward slash in front of it. So but we have the button released when we run this the first time, and then it's going to read this line, and it's going to go back to N64, which is right here, and it's going to rerun the boring head as many times as we need to until we say, okay, we got it out to size. We push the block delete button, and it'll jump over this line, and it changes to the next boring head, and we do the same thing over again with this boring head. And it goes back to 65. When we get it to size, we push the block delete button, and it skips over this line, and it goes on. So I just wanted to show that on the in the program, those few things. This is the simulation in the CAM software. Let's just run through that real quick, just so I can show you what that looks like. look at how we're aligned here. I put the casting about where I think we should go. Only reason I got this 2-inch indicator here is because when I'm up close to this side of the casting, it kind of gets in the way of this thing here, so I want to get up close to there so the 2-inch indicator will clear that. I don't hardly ever use this 2-inch indicator. I just want to see how we're aligned here. Not to be perfect, but to be sort of close. Okay, it's about get up here a little ways. About 30 thousandths that way. Let's see what we're doing down here. Let's go in the other direction down here. It's falling off a little bit because it's compressing the indicator. The needle goes this way, so let's see what we're doing over here. Casting's tilting about 50 thousandths of an inch here. Probably won't be a big problem there. What I plan to do is I plan to probe the casting right around in here, set my 0 point. Well, the 0 is up here really, and so I'll probe it there and calculate the 0 for my Z0 on this side of the part here, and then once we establish the 0 point, we can calculate the X0 here, and we already know the 0 from our 0, our fixture offset here has the 0 X and Y here, so we can calculate that back knowing the center of rotation of the pallet in the machine, which I'll show in the code. But just want to check this a little bit to see if I'm kind of more or less where I want. When I set the casting on this fixture, I check this. It's sort of important that this be square so that when I put the side holes, let me move the camera up here a little bit. This side of the casting be square to the fixture. I'm assuming the fixture's parallel to the machine, and not bad. I mean, it's, you know, it's a casting, so it's not going to be perfect. And then check it underneath here. So it's more important that this be square than this down here. Put the camera back a little more here. Then this down here be perfectly, you know, parallel to the y-axis up and down. It's more important that these sides here be square, or you know, straight to the z, parallel to the z-axis, if you will, in this direction, so that when I face this face off and this face here, this face and this face are going to be faced in this operation, as well as the end of the part. And to square this up, although this distance has a plus or minus 1/8 of an inch tolerance on it, so it's not that critical. You just want to make sure you get it, I guess, tangent to these radiuses. The stock comes out on this casting here, and this is where the gates of the casting, where you can kind of see them. Here you can see it, and so all this is going to get face down, but we want this to be square to the sides, more important than up and down here be parallel to this, because when we go to the next operation, we got holes and spot faces to put in the sides here, and we want those to be, well, we want it easy to get those in there. We don't want this way off to where we have to continually adjust offsets or something to get that in there. About a tenth of a thousand under the nominal. Just check it with our gauge block set to make sure where we're at. Okay. Right on the 0. Kind of hard to do it right here inside the machine. Pretty much right on the 0. It's finished. I don't like the way these holes here look like they're not really centered in these bosses here. I went with their drawing dimension. Their drawing dimension is a dimension from this radius, if you will, to the center of the hole, and I went with that when I set this up. But I'm thinking that I need to move it, the whole setup, over this way more, and maybe I can't go by their casting drawing dimension here, and over here it didn't quite clean up here and here, you know, on these ears in the right way. So I don't know if this part's going to be alright or not. There was one other problem I had was with the reamer, this 1/2 inch reamer. It reamed these 3 holes fine, But this hole, it reamed oversized out of tolerance, which is odd because it reamed this hole, then that hole, and then that hole, and that hole's fine, but this hole up here is too big. I don't know. I generally don't like reamers because they have these issues with them sometimes. This also is a reamed hole, 3/4 of an inch. So I changed all this to boring heads. I'm going to bore this bore, this 3/4 of an inch, and these 4 1/2-inch dowel pin holes, because they have a 1/2 thousandth tolerance on them, and this has a 1/2 thousandth. This has 8/10 thousandths tolerance on it. And I'm going to bore these 3 holes instead of reaming them, because in general I don't really care for reamers. You have problems like this with reamers sometimes. I don't know, maybe if I put oil on the reamer it would be better, probably, but I'm just going to do away with that issue completely and bore this hole, these 4 holes, and this bore of course needs to be bored. I think a bearing or something possibly fits in this bore. I'm going to shift the whole setup over this way a little bit. Need to do a little inspection here of the part. So let's go and set our part. We set the part up here on a kind of a jack screw underneath here, because this is a milled surface on the bottom, and so it's holding it pretty square against, you know, in this plane here, which we're going to measure up and down here and check the dimensions of the holes in relation to the drawing. So we're going to set our 0 point on this bore. So in order to do that, let's go looking at the screen here, the control of the height gauge. We're going to set and measure, I'm going to push this button, but I'm going to put you over here and show you how this works. When you press that circular measure button, it's going to go down and you scan the bottom of the bore, get the minimum dimension, push enter, and it comes up here to the top. It'll beep, and then you scan the, and you can actually just push this down when you're done. It measures the diameter of the bore, which in this case, if you remember when I checked it with the dial bore gauge here, I said I was like a 1/10 of a thousandth. The middle of the tolerance is 2.404. That was about a 1/10 less than that on the bore gauge, which is pretty close. It's 2.4023, we'll round it up. So that's pretty darn close. Now we're going to set our 0 point at the, getting kind of a lot of glare. I don't know what to do about it for these lights up here. But we want to set our maybe if I get up here higher with the, if we want to set our origin at that, we're going to select the origin key here. We have to select this. Maybe we select this, and we select the last hole. I've only measured the 1 hole, so we set that, and we make that 0. Enter. So let's inches. Excellent. Okay, kind of a sort of a setup here. I'm going to set our 0 point right here on this bore again. Okay, let's look at this up here. Maybe I can get my angle better here. Okay, we want to, that's the bore. We want to set the 0 on there, and the last hole we measure, and make it 0. Okay. Looks good as far as the locations and everything, sizes, except for that one hole that I talked about, this hole that I talked about earlier, that the reamer cut oversize on for some reason. Here's the measuring tools required to measure this operation on this part. Got the dial bore gauge for the 2.44 bore, 3/4 inch bore, 1/2 inch bore, depth mic, depth caliper, and 2 dial calipers.